Okay, there are two ways we can do this, and what you just responded with was, I think, a picture of where we are in the unit circle. Okay? And on the unit circle, here's our x-axis, and of course here's our origin. And we start out here, right? That's at negative 18 centimeters. Of course, radius 18 centimeters. Okay?
Isn't the radius 180? Because of the length of the...
No, because we're modeling the position x, and we're releasing from 18 centimeters, so it's not going to go to 180. If we release it from here, it's not going to go out this way. It's going to go back toward equilibrium, and then to an equal distance on the other side because of energy conservation. That's being an ideal pendulum. I mean, in reality, every swing is going to be a little shorter than the last one. Every distance from the origin is going to be less. Every maximum distance from the origin is going to be less than the former, than the one before it, right? That's why you got to wind up your grandfather clock. You got to supply that little bit of lost energy with every tick. Okay, so you're starting here. That's where your position starts, and it's going to move this way, right? Of course, there's only one way it can move if it's released from rest. It has to move back toward equilibrium because that's the direction of the force. Okay, so phi. If I do 18 centimeters times the cosine of phi, t equals 0, I'd better get negative 18 centimeters, right? So what does phi have to be?
Pi.
It has to be pi because the cosine of phi has to be the negative 1 you need to make this into a negative 18 centimeters, right? Is that clear? If not, review solution of trigonometric equations. Review your circular trigonometry. You got to be good at it to understand what you're seeing here. Okay? So, one way, well, if you look at this picture, here's your t equals 0 position, right? So, what's your radial vector? It's this. Pi radians are 180 degrees, right? Make sense? It's obvious from the picture that it's got to be 180 degrees, so the solution to the equation better be this. So that's so here's phi by the picture. Phi by the equation. X of 0 is negative 18 centimeters. X of 0 is 18 centimeters times the cosine of omega times 0 plus phi. Now you won't always know that this is at 0. Like you've already got your device or your time, your clock or whatever is already moving, and you observe that this thing is at some position at some instant, right? So t might not be 0, but you're still going to get a definite expression inside here. And since you're going to solve by taking an inverse cosine, that expression is going to be equal to some multiple of an inverse cosine of something, right? Okay, so in general, you won't have 0, but x of 0 then being negative 18 centimeters has to equal 18 centimeters times the cosine of phi now, because in this case, your initial time was 0, right? Okay? Well, it's very clear. We divide by the 18 centimeters. We get the cosine of phi equals negative 1. and we know exactly what phi has to be, but we'll say it's the inverse cosine of -1, right? Okay? Then I said something wrong a while ago. I said the inverse cosine is between negative pi over 2 and pi over 2. It's between 0 and pi. It's inverse sine is between negative pi over 2 and pi over 2. Okay? And you know that. And if you don't, make sure you do. And now you know that x of t is 18 centimeters times the cosine of 2.4 radians per second times t plus pi. It's okay to write 180 degrees. When we're talking about the unit circle, a lot of times we do it in degrees because multiples of pi are, what's 2.57 pi? You got to stop and think, well, that's in the second quadrant because it's between pi over 2 and pi. It's a little shy of 3.14, You don't want to have to do that. You have an intuitive understanding of degrees, and that's perfectly okay here. But if you're going to use degrees, write degrees. Okay? Fair enough? Okay, well, there it is. Now you know what your velocity function is? How do you get your velocity function? Definition of velocity is?
Radians per second?
That's omega.
Now, then it would be easy to make that confusion because we do angular motion on a circle, but right now we're projecting the angular motion on the circle onto an axis, and now everything's in units of distance, right? So it'd be what now? Well, the definition isn't, instead of radians per second, it'd be centimeters per second, or convert to meters, meters per second, or miles per second, parsecs per second, whatever you want, okay? But the definition of velocity is what?
Change in position with respect to time?
Expand that just a little bit. There's no such thing as change in position with respect to time.
Change in displacement with respect to time?
Position and displacement are kind of, displacement is a difference in positions. What's the definition of average velocity?
Final velocity minus initial over t.
It's not the definition we use. It doesn't connect anything to anything. It's the average rate of change of position with respect to time. You didn't use the word rate in your definition, okay? You said change of position with respect to time, or something like that, okay? If you'd have said rate of change of position with respect to time, then you would have had something that didn't crash your spacecraft into Mars. Didn't run the Parker probe into the core of the sun. Not that it would make it that far, okay? Parker probe works. You know why? Because you're not yet working for NASA. But, you've got a few years to go before you're ready to work for NASA if that's your ambition, okay? And maybe you're good enough, so I told you how good you gotta be. Be as good as you can. Okay. Sloppy definitions. Do not use sloppy definitions. They mislead you and they cause errors. Okay? Average velocity is average rate of change of position with respect to time. And velocity is what?
Average change of position with respect to time?
Average change of position?
Wait,
There's no such thing as average change of position with respect to time. If you're doing a rate of change of something, a change in something with respect to something, it's a rate of change of something with respect to something, and you have to use the word rate. Okay? Again, try to clarify your definitions. Because since we're working from principles, you've got to have good definitions. Okay? Now, I didn't ask for an average velocity, so saying it's an average rate of change of position with respect to time is not going to tell me what velocity is. Tells me what average velocity is. What's velocity?
Rate of change in position over time.
With respect to
With
time.
respect.
But over time, I mean, that's an easy thing to do, but with respect. Which means it's the derivative of position with respect to time. There's a reason it's a derivative, right? We can define it as the derivative, but we want to say what the derivative means, because even though we've had a year of calculus, or a year and a third of calculus, depending on, you know, whether you're taking the multivariable right now or not, we have to understand what a derivative is, why we're using it, in terms of what happens in a small interval and a limit. It's the limiting value of the average rate of change of position with respect to time. I said it's a limit of. The precise limit, well, I'm not going to define that right now, but that's easy to define. Okay? It's your difference quotient taken to a limit. Okay? And your difference quotient is always a change in position divided by a change in time. You know, for a position function. So we can say if we understand definitions, your velocity is x prime of t. It's an easy derivative.
Negative 18.
Yeah, but I'm not going to take the derivative of that. I'm going to take the derivative of
Oh.
this, okay? Because we want to go back to the original idea. And then that equals negative 2.4 radians per second times 18 centimeters times the sine of all that stuff that goes inside, which is not any different than what it was here, okay?
In this case, just negative 1.
And then 2.4 times 18 is 40. And that becomes centimeters per second, because this is radians of arc on an arc of 6 for 18 centimeters, your picture here, right?
Don't worry, I'll come back. Actually, no, it would be 0.
Because you pick the derivative of cosine. It should be a negative sign.
And your
It is
acceleration,
negative.
which you can work out easily enough. Okay?
Stop.
Make sense?